I want to start about a story about that restaurant. So the restaurant is Budokan. By the way, I live in San Diego, so it's been 20 months before I visit New York City. But last night we went to this great restaurant called Budokan. And let me read you the menu. Sorry, if you missed it, maybe you can make it up tonight. Appetizers, pork buns, charred pork belly, spicy scallions, and Napa cabbage. The next one, short rib and scallion pancake. And then tuna tartar spring rolls. I feel like this morning, when we heard those keynotes, I feel like I had those appetizers. By the way, yesterday, for people who went to the dinner last night, after the appetizer, we're like a full. We're enjoy the food so much. It has so much taste, context, richness. They really feel like a full. And this morning's talk is exactly like that. Besides our CEO's inspirational talk about acceleration of graph and how do we do graph for all, but also keynote speak. Rohit from MasterCard talk about AI revolution by reducing the cost of prediction to zero, right? That's game changing. And in the end, he showed what's the trick. The trick to accelerate prediction is to reframe the AI problem as a graph problem. That's huge. And then Steven from Teradata talk about the influencer using social graph, and that's how you can get beyond just simple connections done by relational table into a deep graph link analysis problem. In that sense, he also concluded, using graph, you can greatly accelerate or augment your AI to a level you could never done with traditional AI. And then the third part, George, literally, there's a very simple theme out of his talk. He literally talked about big data is big graph moving to the future. So those are the three great keynotes in all the talks this morning. But at this talk, I hope you still have appetite for the main course. And the main course here is Graph plus AI. What's next from from Tiger Graph point of view, and it is about democratizing graph adoption. So with this, I have a great partner with me. So this is me. I'm not going to repeat all the stuff there. You can read about it. I got my PhD in computer science with deep in big data technology infrastructure back in the 90s. And then since then, I worked for many companies, including Teradata. A lot of us with deep roots in Teradata. Back in the 90s, they were the only company can handle 100 terabytes of data for Walmart. They were way ahead of the time, and we were able to leverage that kind of called MPP technology to graph. And then by the way, I'm a newbie to Tiger Graph from a professional point of view. I just joined Tiger Graph 2 months ago as VP of Product and Innovation. But before that, I was very familiar with Tiger Graph and Graph because last 4 years when I was at Intuit, I was leading the end-to-end data strategy and architecture, connecting all the silos data for 150 million consumers and 6 million small businesses together. And I led 4 teams, did a comprehensive benchmark against all the graph technology. That's how I discovered graph. That's how I discovered Tiger Graph. And we picked Tiger Graph to implement 4 production scale use cases to handle more than 1 terabyte of data each, ranging from fraud detection to entity resolution to customer 360. That's how I'm actually bringing the product perspective, bringing the customer perspective to the product strategy and also innovation here. With that, I'd like to Victor, my co-presenter, to introduce himself.
Hi, I'm Victor, and I'm just going to say a very few brief words right now because I'll be back later to speak. But I've been with Tiger Graph for about 7 years now in a variety of roles, and I ended up here from starting out as an electrical engineer doing circuits, which are a form of network. I then was out of technology for a little while. I was teaching believe it or not, English as a second language to adults. Okay. And then that got me into thinking about semantics and language and the relationships, how different languages have similarities. And that got me into looking at how abstract things can be structured. My tech background caught up with me, and I ended up being a data analyst for the adult school. That got me into databases, and then I went on to grad school to study databases, and then I was introduced to graphs. And that seemed to put everything together, and so I've had the opportunity to both be an educator and to be a technologist, and now I have this, to see GraphML come about has been really exciting, and I'm going to be excited to talk to you more about that in a little while, but first I'm going to let Jay talk to you about graphs in general.
Victor. All right, we have an action-packed agenda for you. I know we're standing before you at lunch. Please bear with us. You need to finish this main course before you can go to the main course for lunch. So we're going to start with a great simple graph overview, but most focus on a lot of people you may be wondering, especially you're new, what are the barriers? Why it's not easy, at least right now, for people to adopt graph? And then I'm going to show you all the great success we have, high level, but most importantly, what's behind it, how they were able to overcome those barriers. Then I'm going to introduce some of the brand new capabilities feature we just released end of last month. We have this release called 3.2, one of the major releases after 7 months of hard work. But what I'm most excited today to share with you is the future, to show you what's in the pipeline, the innovation, the game-changing, innovative work we're doing to accelerate the graph adoption. And then Victor is going to share the exciting advancement we have in terms of machine learning and AI. So one of the greatest leadership lessons I learned from Intuit, which is one of the great leaders there called Brad Smith, was able to lead the company through let's say, a 20 billion company to a 150 billion company today. He always tells us repetition does not ruin the parade. So I'm going to repeat a little bit about some of the theme you heard this morning. The first thing is Gartner Research predict by 2025, 80% of the innovation related to big data is going to be about graph. You know, starting from this year, it's about 10%, 8x growth in the next 4 years. To graph or not, that's not a question. You will graph. The question is how and when, and this is what our presentation is going to share you from our Tiger Graph's perspective. It turned out a lot of business leaders, the innovative leaders, the pioneers agreed with Gartner's research. And this includes Brad from JP Morgan Chase, realizing after leading their team through the graph journey, realized graph really clarify relationships. And with that relationship, you can get deep insight no other technology can give you. Harry Power, this is actually one of the biggest use cases we have in Europe with Land Rover Jaguar. And he led a digital transformation there, and then by implementing a gigantic supply chain optimization use case on top of Tiger Graph. And they were able to demonstrate with the graph technology, they're able to reduce the planning time from 3 weeks to 45 minutes. And he was able to attribute that to their $100 million incremental growth. And Ed from United Health was mentioned a little bit this morning by our CEO. They created this gigantic, probably world's largest customer 360 or patient 360 graph with 8 billion nodes. That was 2 years ago, now probably already double. And with that gigantic customer 360, they were able to understand customers' journey, they were able to predict, and they were able to be proactive to manage customers' need. So if you look underneath it, this question is why graphs become so big? Besides all the things to talk about, there's a fundamental reason why graph is so big. It starts with the explosive growth of data. IDC predict by end of this year, we're going to have 80 zettabytes of data in the world. What is a zettabyte? It's a billion terabytes. That is a lot of data. And today, no matter which organization you're in, you're always being faced this data silo problem. Some of those with legacy, some of those by design. If you have merger acquisition, if you want your team move faster, you want each function sometimes pick their own technology choice. They have to have their own view of the data. They'll model and present their data in the way that's optimized for their function. But as a result, those data are dispersed, disconnected, disorganized. So make it really hard for you to look at holistically. That's a huge challenge, combined with the data growth. Then people spend millions, tens of millions, $100 million moving those data to data lake. That's the state of art, right? Leveraging the cloud storage, cheaper storage, leveraging the compute, right? And they believe by doing that, they can solve this problem. It turned out most of those projects become a data swamp, right? They literally directly bring whatever they have just to the lake. And then those are relational by nature. And then they rely on other newer technology, which is great technology, like Snowflake, Redshift, keep combining those data together. But if they're not careful, then the data becomes smelly, becomes stale, becomes a swamp. So this is what we believe. Graph can naturally connect all data together in an elegant, simple, and also very efficient way that no other technology can do today. So let me tell you why and how. So let's first start with a very simple representational graph. I know this example probably really simple. It's not an insult of your intelligence. Just bear with me. Okay, in a real e-commerce system, you start with order. Order is basically a customer place an order. Order includes a product. You do the payment for the product. And then, of course, you need to notify the supplier to ship the order from a source destination to a target destination. See, this is a simple way to tell the rich story about how all these objects relate to each other. And then on top of that, you can easily add additional relationship where you say a customer knows each other. Just like what Stephen pointed out in the influence, right? Customer may influence each other, right? If you actually instantiate that into a real database, like a Tiger graph database, then you basically say, Jay placed an order of iPhone 13 from Apple, shipped to his home state, California. Victor somehow wanted to do something different than Jay, ordered a Pixel 5 from Google, also shipped from China, but shipped to his home state, Ohio. If we put all both data into a graph database like Tiger Graph, we automatically connect dots together, right? In this particular case, China is the shared source shipping from for both orders. And then we can lay out additional information about Jay knows Victor because they're a colleague and they're presenting together here at the conference. We can add even more connections there. So what is graph? Graph is very intuitive. You can show this to your 7-year-old. They will understand. And try that other technology, tell your 7-year-old, see if they can graph within 10 minutes. Graph is very meaningful because all the nodes, all the edges has meanings, has semantics. You can tell the story by traversing the graph. And graph is very insightful. What's the insightfulness is because you can analyze between any two dots, what are all the possible connections between them? Maybe 1 level, 2 level, 3 level, maybe deeper, just like a LinkedIn, your direct level, 2nd level, 3rd level, how they relate to each other. People coming to this conference, we can dig deeper, you may from your social network, professional network, somehow there's a relationship. And that's the insight via graph algorithm, we can discover that for you. And finally, graph is explainable. Because it's visual and intuitive, if you do discover a pattern, you can visualize, show the pattern to see what's going on. Try that with your black box deep learning. How do you explain AI? By the way, one of the biggest impediments for deep learning and machine learning growth is explainability, because you just cannot explain. It's magic. It's also based on your training data, label data. In graph, we carry human knowledge to the data organization and connection, so you don't need training data, right? They're connected by how we perceive the world. So in essence, graph connects data together and elevate relationship to be the first-class citizen. And that's the biggest difference. Now you say, hey, how is this different than other models? As you know, relational database was invented 50 years ago, right? And then later on, we have other data models. Why graph is so powerful? Why graph is different? So let's talk about it. What is relational data? By the way, this actually is based on the blog post by Dan McCurry, who's the distinguished engineer at Optimum, which is for United Health. He was the key driving force implementing that 8 billion customer graph. Relational organized data by tables in terms of rows and columns, right? And then when relational database was invented 50 years ago, it was actually done by necessity, try to deal with the limited store, compute, and memory. Basically try to say, what is the most efficient way to organize the data on the disk, in the memory, so we can quickly run transactions on them. So in that sense, they do a technique called normalization. They're making sure data or information is not repeated. You have to split repeated information out into separate table. When you split out, you have to join two tables together. So what is join? Join is about one column is corresponding with another column from another table. And then if their value match, you say these rows should be stitched together. So that's relational database. Worked really, really well for the last 40, 50 years for transactional data, optimized for it. But then people realize that format, that model is not very good for analytics query. Analytics query are tired of keep drawing things back together. They rather invent a schema called star schema. In the middle is gigantic, the yellow is called fact table. Automatically pre-compute all the joins for you. So you end up with a table with thousands of columns, even more, with a lot of data replicated. But then it really runs really fast for read-only analytics processing, try to aggregate, group things together. So that's the OLAP model. And then people start also looking at this. That one is not efficient for certain cases because there's too much redundancy, too much duplication. What if we store data instead of a table of rows and rows? What if we store them in terms of columns? Each column is a separate store. And these are the columnar database. That's what's behind Vertica, right? The best thing about those is because if you have a sparse data set, very likely you don't have full information about everybody. Very likely there's certain information is missing. Then there's no need for you to utilize the row-based structure. What if you use column ones? And also you get automatic compression, get automatic indexing by using columnar database. Again, all these are relational model, try to be optimized for certain processing. So they're very fit for purpose. Then we came to this word called NoSQL, include key value pairs, including document stores. Key value pair is say I have a very simple access pattern. Given a key, I want to look up something. I don't want to do this complicated drawing using a lot of programmers to do that. Can I just do a simple lookup? So people invented a structure called key value store. And then the other one is, what if we use JSON object, like a MongoDB? Can I store all the information about J and J's order, pack into a single document? So I store once, I can retrieve once, instead of trying to do all these complicated drawing, right? But that itself has also a lot of limitation. How big this document can be? How much data you want to pack there? What about relationship between J's document and Victor's document? How do you capture that? No, there's no way. So all these models are designed to optimize for certain things, but graph is different. Graph is naturally represent the model in its most natural way. Automatically you get compression, you get relationship, you get connectiveness. That's why graph is the mother of all models. Remember that, you can quote me on that. So then you say, graph is so great. Why it's so hard to adopt? Because it's new. It's transformational. It's paradigm shifting, right? So the first question is, what's the value to business? Customer benefit, business value, right? What's new? Because I already invested a lot in the other technology. The second one, is it real? Can it scale? Is that just academic research? Is that just to solve some toy problem for POCs? Can I use it for really real for my terabytes, 10 terabytes, 100 terabytes of data? And then the third one is how hard it is to learn. Am I have to retrain my data scientists, developers to adopt this? And how costly, how much time does it take to build solutions like this? And is it costly to operate? So these are all valid concerns. By the way, when I was at Intuit, we went through the whole process, right? So let me next quickly go through some of the big companies already adopt Graph and adopt Tiger Graph. Actually, it's more than just 500, Fortune 100 companies. The first category of how people use Graph and Graph database like Tiger Graph is to connect all data sets together. So I already mentioned the example of United Health. Underneath it, they were able to use that one gigantic graph, connect 200 data sets together. So that's huge. And then the second category is once you have data stored in the Graph database, suddenly you can run advanced analytics much deeper than what relational data can do. And I mentioned Jaguar Land Rover. It's a great example. There's also a great example, probably one of the biggest telco company in China, China Mobile, is using that for fraud detection and to handle 50 million calls a day. And then the third category is the one Victor is going to share a lot with you, is how do we bring machine learning AI to the data? Instead of currently you have to move data around to build different pipelines for different fit-for-purpose machine learning algorithms. What if you don't have to move your data around? You just need to move data once into Tiger Graph, and then you bring different AI machine learning algorithm to it, which is a set of graph, data science library, and so on and so forth. And that's what we did at Intuit. Our fraud detection use case is very similar to this morning Mastercard's use case, as well as Teradata's use case. Actually, we conclude the same thing. We can use Graph to do what we call deep link analysis, 10 hops, right? For fraudster, these days they're very clever. They set up fake entities, transact with each other. And then we said even more. So as you know, finding fraud is always, cat and mouse game. How can you be ahead? The only reason is you have to go really deep. Your shallow algorithm will not work because they already know how you can detect them, right? This is huge. So also we're seeing not only across industries, but also there's a lot of different use cases. I don't have time to go through all of them. Feel free to talk one of our a great sales team or partner team talking about the use case, because this use case is still growing. Graph is everywhere. Underneath every single problem, there's a graph way. The question is, can you discover that? Once you discover that, you'll bring AI ML to the level you can never accomplish with a traditional AI. So let me tell a little bit how, right? How those customers were able to overcome those barriers. Of course, you need a very performant and scalable database, graph database engine. That's what Tiger Graph offers. I don't have a lot of time, but if you look at this in the bottom, that's really the MPP architecture, massive parallel processing architecture. From actually the large-scale relational one, that's where I actually went to Teradata for 18 months. Yushu, our founder, spent 6 years there. We know what's going on underneath the world's largest scalable relational database engine. How do we apply to Graph? That's exactly what we did at Tiger Graph. And then on top of that, so the compute, the store can be infinitely scaled, meaning you can spin up as many nodes as you want. And that's how we can accomplish much bigger data set than our competitors. And then in the middle layer, we deploy a messaging layer, because how do you coordinate among all these, tens of 20, 30, 40, or hundreds of nodes doing compute and store? That's where the coordination happens. That's the Kafka messaging and so on and so forth. Again, I don't want to spend a lot of time go too deep. And then on top, this is where, how do we expose that power of graph database to our developers via a graph query language a graph SQL language like SQL. I'm going to talk a little bit about that. They're a very easy to use a Visual Studio for graph developers. The IDE tools George talked about, as well as a RESTful API, so your runtime application can easily leverage the power of the graph. And then we can take data from all the different sources, and then, of course, we can produce data, not in batch, on demand, and then allow you to bring many UI application on top. So the fraud detection one is more than just a back-end algorithm into it. Also comes as a front end, so a fraud investigator can easily tap into the result of the fraud detection and then also augment with human data with feedback so that this system becomes better and better. The second part, as I mentioned, is any powerful database have to have a powerful language. SQL has been around for 40 years. What is the equivalent of SQL for graph? And this is where Tiger Graph is very innovative. Figure out a way to make it practical, make it easy for people to adopt. I'm showing you an example of what the graph query language is about. If you remember from the example I talked about early, right? There's an order, there's a customer, there's a product. So this particular segment of the code shows what the query language look like. For people familiar with SQL, you see familiarity. We have select statement. We have from statement. We have where statement. The only difference is instead of you select from tables, we allow you to select from a graph traversal path, right? In this case, what's the relationship between a customer to a product? They go through order in the middle. And when you go through that path, that relationships, we allow you to put expressions on it. In this case, I'm trying to find all products category, matching the category I'm interested. So this query, this simple query, if I remove all the comments, only 3 lines or 4 lines, really it's calculating, tell me all the customers, for example, for one particular product, a toy, what's their spend? That's the query. And that itself, you may argue this is a relational query. Yes, we can actually do relational query, but we can do a lot more. I'm not showing here, which is Graphql algorithm. So this SQL language is schema-based, meaning we based on strong typing, based on whatever the graph schema I just showed here. It is inspired. It follows SQL. You can see that's the extension to SQL. Did it in a very clever way. And also, it is parameterized. If you think about when you write this query, it's not like for toy category, you write 1. You can pass in as many parameters as you want, right? And then also, what I'm not showing here is the language. That's where we go way beyond SQL. We add a for loop. We add a while loop. And these are necessary to implement really sophisticated graph algorithms. And then the other thing that's what's unique about us is it's edge tab. That means we support both transactional and analytics in one single database. Some of the graph analytics platform is read-only. You have spent expensive time or cost to get the data out, build a pipeline, and then feed into this read-only engine, and then do graph processing on top of it. But imagine if you want to do near real time, when things happening, you want to rerun the algorithm right away on the spot. And within seconds, you want to know the result. You cannot do this read-only analytics platform, graph analytics platform. We offer you doing that. So I'm a little bit behind. I'm going to skip a lot of features. So the thing I do also want to emphasize is we see one of the key things about adoption is really to develop a very delightful user experience. This is something I mentioned earlier, is Visual Studio for graph developers. You can use this graphically, visually, can define your schema, can map your data, can load your data, can explore your data. What I'm showing is data exploration. What does that mean? After you load the data, without writing a single line of code, just using this, we can already bring a lot of the graph algorithm to you to help you run those algorithms and highlight those things. So in this particular case, I'm running not a query, just an analysis showing the data, say, hey, what's the shortest linkage between Victor's order and Jay's order? And then as you see the result, we show this path, highlight this path for you, right? Just a simple example. And then we have a way to show visual query builder, I'm gonna show later, and also you can write queries. And then this one I'm going to skip because Victor will spend a lot of time. How do we bring machine learning and AI into that graph database? And then I know we have a lot of partners here. One of the things is, do I have to install new software, maintain new software, right? We'll simplify them by working with all the cloud partners here. And then the other thing we know we're making a lot of great progress is the rapid adoption by the developer community. We have a very engaging, vibrant community. This conference, beyond this in-person, we have people on the internet. This has more than 9,000, maybe at this point already break 10,000 people registered, 3x growth. And we have a lot of growth in other areas, but I also want to point out one of the things you can tell this technology becomes more viable is when the next generation of programmer or developer can easily adopt this. This illustrated in the university program we have. Within 30 minutes, students can start solving real problems using our solution. And that's a game changer. Of course, we also rely on partners in other kind of partners beyond just cloud. Just give you a few examples, right? We realize sometimes it takes too long for you to build a solution on top of the graph database engine. So we partner with Experial to bring a almost turnkey solution to you. If you want to do AML, there's already a turnkey solution. You can just need to do some simple customization, linking your data, the full app is running, right? And then the other exciting area, that's also one of the strengths of Tiger Graph, is we're able to offer hardware acceleration. Our architecture is extensible enough. You can actually take advantage of CPU, the GPUs, and then we're able to demonstrate with some initial partners 20x, even to 100x growth, because the graph is a very CPU-intensive computation, graph algorithm. So I think I'm going to skip this, as this was the foundation. You can do a lot of things. But I want to quickly mention some of the new capability we just introduced last month, end of last month. I said it's more than 7 months of work, a lot of code. So I'll quickly go through them. We introduced these new capabilities. If you're a large enterprise, you want a business continuity, and we actually going to provide that out of the box. You can have a replica running in the different region AWS. As you know, AWS, even though they're all great, but sometimes certain region may have some hiccups. So with that, you don't have to worry about it because we can fail over to other ones. And then the other replica can take queries while it's not a passive replica. We start supporting Kubernetes to simplify the cloud management, the container management, if you want to manage a large cluster of Tiger Graph. We give you ability to control the workflow to separate large read-only query from smaller read-write queries. We give you ability to control access control. I'm going to skip this. There's a lot of great language innovation, as well as the incremental innovation in terms of how we can make our tools much easier to be accessible and then also much productive to use. And then the other thing I want to mention, I think early on we were going to say, the first time we have an industry benchmark created by LDBC, Todd mentioned that. This benchmark was actually created to model a very real use case in the social network, almost like a Twitter. So it's real. The scaling is, we are the first and only vendor complete the 36 terabytes level. And that graph is, how big is that graph? It's 72 billion nodes. It's 10 times, almost 10 times more than what our largest customer 360 graph we know, right? With 500 billion edges. That's huge. But that's not it. I want to share with you some of the exciting new things we're working on. So since I'm also leading the innovation, so the definition of innovation, people may define innovation in different ways, but the way I define innovation is doing something almost from impossible to possible. Also doing something much better, faster, cheaper in the scale of hopefully 10x, but start with 3x, 5x. That's game changing, that's innovation. So we're asking ourselves, what can we do to simplify graph adoption by everybody? As you remember from Yushu's talk, graph for all. We think about, can we get a lot more people to adopt it without learning our language? Is that even possible? Can we get business users without writing a single line of code, can get into the graph inside analytics? Can we greatly reduce the adoption, reduce the time, the cost, the effort to have an end-to-end complete graph application? So I'm happy to share we make a lot of progress there. I'm going to show you the latest prototype is in the prototyping phase. Some of those will go to a release pretty soon. Some of those may take a little bit of time. But let me show you a few things. First of all, I think it was mentioned, GraphQL becomes a very popular language for application developers. Even though that was not for graph database, we're able to create a front end to it. With that, we will let more than 100,000 developers immediately enjoy the language of their choice. With that, let's roll the video.
GraphQL is an open source specification for querying data from different services and data sources from client-side applications. It was invented and published by Facebook in 2015 and now becomes a state-of-the-art API language standard with rapid adoption from application developers in the world. Let me show you how developers can use GraphQL directly to query data in Tiger Graph via our automation toolkit without writing a single line of code. Take this use case shown in Graph Studio as an example. A person can work for a company and invest in a company can invest in another company, and the company can bid for a project. We introduced a brand new Tiger GraphQL tool by running a single command to connect to the Tiger Graph system hosting this graph use case. This new tool first automatically generates GraphQL schema from graph schemas stored in Tiger Graph. This can be shown by using Graphql, an open source explorer, to view the generated GraphQL schema. We can run introspection queries on the schema to review and examine all the data definitions and relationships, and paste the result to an open source GraphQL Voyager tool to visualize the schema as a graph. From the visualized schema, you can see that a person can work for a company, can invest in a company, and the company can bid for a project. This new Tiger GraphQL service can also allow developers to run GraphQL queries directly against Tiger Graph. Let's run a simple query to get a person Tolly's information. Now let's see what other companies that Tolly has worked with. Now let's see what projects the company Tolly worked for has bidded for. What if we only want to see the project bid with a specific bid price? The magic underneath the innovation is the ability to automatically translate GraphQL queries into a GSQL query, so developers can start using Tiger Graph immediately for 80 to 90% use cases before they start learning GSQL for more advanced capabilities. This query shows an example about the translated GSQL query from the GraphQL query. With the new Tiger GraphQL tool, we believe that application developers all around the world will accelerate their adaptation to Tiger Graph to unlock the huge potential for graphs.
I just want to share, GraphQL becomes so popular. There's a there's a company, it's open source. That's why we're able to integrate with a lot of open source tools by having the support. But the company behind this, try to commercialize, is called Apollo. They just raised $150 million with a valuation of $1.5 billion. And then on their website, the download already exceeds, they actually did a survey, 80% of JavaScript developers want to use GraphQL to develop the application. So this is huge. Let's go to the next one. Next one, again, we go to the next level. So what about business users? They don't have the time, desire, expertise to learn about query language. Even though our language is great, SQL-based, but a lot of those business domain experts, it's not their time to spend in learning about those technology. What can we do to simplify that work? And we come up with something called Visual Query Builder. The idea is allow those business users to visually describe what they want. Graph is very visual. Graph schema is a graph. Graph data is a graph. What about express the need? Your requirement is a graph, so we can automatically generate the code for you. With that, let's roll the next video.
This demo, I will show a preview of the latest innovation we are working on in Visual Query Builder to dramatically simplify the job to unlock huge potentials in graph insights and analytics with an example query from the LDBC SMB benchmark. From the schema visualized in our Graph Studio tool, you can see that a person can post in a forum and add specific tags on the post. People can also know each other. Now let's take a look at one of the graph queries defined in the benchmark. The IC6 query is to first find all posts on a given topic that are created by a given person's friends and their friends of friends. Then find the top 10 other topics that are covered together with these posts. With Tiger Graph's training complete language, GSQL, an experienced developer can definitely use concepts like accumulators and control flow to write this query as shown here. While the 25 lines of code looks pretty simple with the familiar syntax borrowed from SQL and extended with graph traversal, it does require time for a new developer to learn GSQL programming from our online documentation and practice with samples before you can master the language and create high-quality queries with confidence. This also becomes a big barrier for many domain experts to use Tiger Graph without the time or desire to learn graph programming in that level. Now, Tiger Graph Visual Query Builder, we are providing a no-code alternative to our query language. You don't need to write a single line of code. Instead, you can just use drag and drop to visually describe what you want to achieve in a what you see is what you get fashion. Here is how the visual pattern looks like. Start from a given person, finding all the person's friends and two-step friends, and get all their posts with a given tag, and then find all other tags that occur together on the same posts, and choose the top 10 tags that occur in most of the posts, exactly what we want. Now let's run the pattern with a given person ID and the tag name, and we get the top 10 tags. As you can see, the original RDBC documentation on this query includes a visual explanation. You can see how our Visual Query Builder allows people to take visual representations of complicated query like that and augment with precise logic described in the text, so they can uncover deep insights from connected data visually, intuitively, and effortlessly.
Great. So what you just see is a tool for domain expert to really have a no-code way. Of course, they still have to express what they want. So there is some logic there. But as you see, they don't have to learn the new language. They can visually describe what they want. Without this, usually what happens is business domain experts have to write down the requirement in the document and then pass on to a developer, and developer translate that into whatever the language and run it, including SQL. With this, we can remove that intermediate step. So next one is also very exciting. So next one is, I said, is there any way to simplify building graph application? Because even if you get Tiger Graph, the most scalable, the really easy to use graph database platform, you still have to spend time building the schema, writing the query, leveraging the graph algorithms, you build a service layer, and then you have to build UI on top of it. That usually takes a long time. So what can we do to simplify that? So number one, we can look at across industry, what are the things people are doing? We partner with domain expertise. We can actually build those things, bring those as a solution template to you. So let me show you one of the new ones we're developing called Data 360. Let's actually roll the video.
Critical decision systems and enterprises are often composed of hundreds of complicated data pipelines to move data from various online operational databases to offline data lakes to the final target systems that generate business intelligence reports and dashboards. If one of the immediate jobs is down due to changes from upstream components, ranging from software updates to system upgrades to data schema changes to data API changes, these reports or dashboards become unavailable or delayed. This would cause serious consequences, making the wrong or suboptimal decision in the dark, which would lead to big revenue loss and missed opportunities to overtake the competitors. Tiger Graph's Data 360 solution is designed to tackle this problem head-on. With the state-of-the-art scalable graph database technology combined with built-in visualization monitoring and reporting. Let me show you a demo of the solution via a sample use case. Once logged in, you'll be prompted with all the processes in your system. The top table is illustrating the upstream processes from your reports. You can toggle the number of report dependency flows that you'd like to see with their critical dependency scores. The search capability easily allows you to find certain dependency flows. To examine the process, let's click on the dependency flow and maximize our canvas by removing the side nav. Here we can see one of the table schema change dependency processes. When hovering over a node, you can see upstream and downstream processes highlighted. On the right, you'll have the ability to see information related to a process currently highlighted, along with the upstream and downstream and full dependency flow. Clicking into the settings, you'll have full control to modify any of the settings in your canvas. By selecting a different color schema, you'll notice all the processes have changed color. Going from reports to the admin panel will allow us to see a 360 view of all of our processes by categories, along with the top 10 critical processes based on their scores. Below that, you'll have all your processes in one view with the colors corresponding to the score's criticality. Clicking on the tile, we can navigate back to the process dependency flow, where you can examine the dependencies that flow to the upstream reports. Let's also take a look at the downstream table schema change dependency flows and filter on the top critical dependency scores. We can easily identify the dependency with the highest risk. Clicking on the tile, we can see numerous dependencies that are connected to the table schema change process and begin to examine the dependency flow. Lastly, we'll take a look at the processes tied to stakeholder risk. By using the filter and clicking on the tile, we can make our way back to the dependency diagram. As you can see, the process dependencies can get quite complex. However, by using TigerGraph and the Data 360 UI, you can easily track, monitor, and use graph-based analytics to proactively address all your data dependency flows.
Awesome. So what you see here is something we call Data 360. We talk a lot about Customer 360. We talk about Patient 360. We talk about other things. Graph is about linking everything together. This is actually a universal problem. When I was at Intuit, we're facing that as well. There's so many hundreds of mission critical reports. Sometimes we don't know where they are. Sometimes we know they're delayed, and that actually has very negative impact to making your real-time business decision. So with this, we're able to allow you to monitor all your system, the data in and data out, because each system may be up and down because you have upgrade, you have upgrade, you have API change, you have data changes. All these things can cause one of those jobs to be down. And when that job is down, your end decision support query will be delayed or will not be available. So this actually what we get to is with solution like this, then we can easily show the business benefit of value. And for a lot of customers look at it and say, yeah, that's almost what I want, 80%, 90%. Then we can easily figure out how to do customization to fit the need, to actually connect with the data, to connect with the real-time monitoring system, so that give you a 360 view. But what's more also excited is how many of the solutions we can do? We cannot do too many because we're limited, right? As I said, we already know across all industry, all kind of use cases. So besides partnering with our solution partners, we'll also figure out technologies. How can we quickly package all the best practice learning together? So that's the next part I want to show, is something called a solution accelerator. Let's roll the next video.
Demo shows how an end-to-end graph solution like Data 360 can be built and deployed by leveraging our latest innovation in Graph Solution Toolkit to accelerate the time to market on graph applications. First, let's give a name to the graph solution. Next, we allow you to choose the vertical industry from the list, ranging from healthcare to retail. Here I've chosen data management. Then we will present you with a number of known use cases that are relevant within that industry, from metadata management to data compliance. I will choose the Data 360 use case. At this point, we allow you to specify what kind of data you want to bring into your use case. For this demo, we generated a synthetic data for you based on industry best practices. You can preview how the data looks like by clicking on each table. Based on the dataset you selected, we automatically generated the Data 360 graph schema here, including entity types expressed as vertex types in the graph and the relationships as edges. As you can see, this is the DB table vertex type, and this is the BI logical table vertex type. Since the distinct advantage of the Data 360 solution from John's demo earlier is the graph insights, we also allow you to include out-of-box insights in the solution. Let's include the critical data dependencies and critical failure prediction. The next step is to configure a UI experiences. In this case, I'm selecting the full application UI instead of BI dashboard. With application UI experience, we included a few modules already supported out-of-box while allowing you to build customized UI modules. I will just select the pre-built modules. Before we generate the code for the entire solution package, we will let you review what you selected. Now we are composing your solution. This diagram shows all the work we are doing underneath, including generating the code, compiling code, generating schema, and loading scripts. Finally, packaging the code into a tarball that you can download. I will skip downloading and continue. Great, the solution is ready. Now let's focus on the final step to deployment configuration so that we can bring the generated solution to the desired environment. In this demo, we deploy the backend to TigerGraph Cloud and deploy the application UI to Heroku. Once you click the next, the TigerGraph schema queries are installed and compiled to a TigerGraph Cloud instance or cluster. Data loading jobs are installed and initiated to populate TigerGraph database. The application server, middlewares, and the front-end artifacts are deployed to Heroku. In addition, connection between the application and the TigerGraph Cloud instance will be established as part of the deployment. All these are shown in the animation below for what is behind the scenes. Once the deployment is done, you can access the application as John demoed earlier.
Great. So what you see here is a game-changing way to really greatly accelerate the development of end-to-end graph solution application. We believe it's going to create at least 3x reduction in your development costs. You can calculate how much resource you need, how much time you need to build that. We can also bring your solution to market to be in the hands of a customer much, much faster. And so anyhow, I'm just giving you a glimpse. These are all technically feasible. We're in the process of making those as a product and solutions. We want to work with partners to make sure scale that up so we can have a coverage on many, many industry and many, many use cases. With that, I'd like to hand over to Victor, talk about really exciting advancement in graph and ML.
So thank you. Thanks, Jay. Thanks to our keynote speakers who I think have given you a real wealth of information today. And I feel like my job has been made so much easier because there are things I'm not going to have to explain to you because they've already been presented to you. And so I'm actually going to take this opportunity to try to reinforce those messages. You've heard a lot of information. And it's, as Jay said, it's worth repeating. And because also as an educator, I know that repetition is really important and trying to give some examples and to show how things tie together, and that's the power of graph, showing relationship. So this is the Graph Plus AI conference, right? And we've talked to you a lot about graph, and we've also started in the morning talking a lot about AI and ML, and we have seen, particularly from Rohit, of why they work well together. We also saw from Stephen Props from Teradata talking about graph algorithms and why they provide that AI-type insight. So I'm just going to kind of give our perspective on that and try and reinforce what they say. It's a natural merging because what does a graph do? It shows how things are related to one another. What are you trying to do with AI and machine learning? You're trying to predict or understand how things are related, how they correlate. So the graphs give you that data infrastructure, that data model for doing exactly what you're trying to accomplish with machine learning. Second, those relationships are meaningful. And that connects with another point I have about explainable AI. Because in a graph, you choose your data model, you choose relationships makes sense according to your business use case. And say things are related, they're related because they make sense in your context. And this enhances what you're already doing. It can, in some cases, it can replace your existing ML, but in a lot of cases, it's really an enhancement, it's an enrichment. It's providing it's adding features to your data. It's adding richness to the data. It is boosting the return that you see from your models. And so it just adds on. And as I said before, the meaningful relationships lead to explainable results. There's this duality about deep learning today. Deep learning is basically taking neural network technology and going deeper, going many layers. And it's been able to produce more powerful predictions than before, but at the cost of those, it's using what's called hidden latent layers of variables. And those variables are not the explainable ones that you created. They're ones that are being auto-generated by the system. And it's almost impossible to put into words what they mean. But when you're based on graph, you can trace back to the original meaningful relationships and you can get explainable results, which that can be useful within your own business so that you can have some trust that your model is doing the right thing. It can be trust your customer can understand why you're recommending something. Your auditor, if you are, for example, doing anti-money laundering and you need to explain to the auditor why your process is giving accurate accurate AML predictions, you can refer to this explainable model. Okay, so what does TigerGraph have today? As George said in his 4 pillars, that graph algorithms and analytics are the first historical thing. So they've been around the longest. Algorithms themselves have been around for centuries. TigerGraph from the beginning intended to support graph algorithms, so it's been fundamental to what we do. We now have a library with more than 50 graph algorithms. Stephen Prost went deep into talking about centrality, influence algorithms. He also talked about community detection algorithms. So we've recently doubled the number of algorithms we have in that area. And the great thing is that they run within our database. You won't need to export your data. We're not just a data store. We are a data analytics system. So you build your data, you can update it in real time, and you can run your analytics right there. The algorithms are open source, meaning that you can see they're written in the GSQL language, which Jay talked about. And it means your data scientists, if they need to customize it, they can customize the algorithm to meet your particular needs. It's also running on the TigerGraph scalable, massively parallel processing platform, so it's going to be very performant. And I think as, let's see, Stephen Prost was saying, when he went deep talking about the different algorithms, they're really like a toolkit. You've got a business problem, and what are you going to use to solve your problem? Algorithms are this wonderful toolkit where one or two or some number of them in combination can often solve the need that you have, and if you need to customize it with TigerGraph, you can. So they really are the keys. Just like every developer learns some tricks, every tradesperson becomes familiar with the tools of their trade, graph algorithms are the tools of the trade of graph analytics. And then again, I think both, if I don't know if you caught it, but Rohit talked about graph features boosting the results. And actually, he had a graph of real data. And so I love that he could show that in a real business case that graph features were improving his results. I just have this cartoon. And so now you can trust him more than you can trust me, right? So I'm saying with your tabular data, you have so-called features. To a data scientist, features are the columns in your table, like for a transaction. What was the date? What was the amount? Who is it from? What account is it coming from? What account is it going to? And he said, you know, they had sort of exhausted the features they could get out of their data. And then he said they turned to graph, and suddenly they had hundreds more features. And it's those features that give you the potential for more accurate modeling, because it's quality in, quality out. If you have very few features, you're not going to be able to make a very good model. You don't have much to work with. But when you've got more features, then you've unlocked the potential to really get great results. And that's what my little cartoon, and that's what his real data was showing. And where am I supposed to point this at to get it to work? There. I'm going to go through these a little bit more quickly because you've already heard about some great use cases. And I'm going to kind of try to step back and look at the big picture because you know, that's what an analyst tries to do. You can be a domain expert and know a domain really well, like healthcare or insurance or credit risk. Or you can be sort of a generalist and look at the broad picture. And, I don't have the luxury of being deep, so I tend to be more of a generalist. So when you look at healthcare, one of the problems they're trying to solve is how do you diagnose things better? How do you look at an ailment and decide what treatment this patient needs? Well, if you work for a big medical company, a big insurer, like some of our customers, they have a huge database and they form it into a graph and they find similarities, and they're going to find, oh, that situation has actually occurred before, and the only way they can really see it efficiently is as a graph. And then as a graph, then they can make better recommendations. That's improving healthcare and lowering healthcare costs. So it's a win-win for everybody. In the second case I talk about, industrial supply chain, well, supply chains are graphs. They're modeling how the different components come together to make the final product, and that's pretty straightforward, and there are supply chain software products out there. But if you really want to do a good job, you have to bring other layers, other levels of analysis into the problem. You know, it's not just the physical combination, but where are those parts coming from? What are the transportation and assembly logistics? What are the costs? And what are the the logistics obviously is a big issue today. You know, we've had the pandemic has brought about all these supply chain issues. But there are cost structures. There are perhaps certain contractual agreements you have where there's going to be a penalty if you don't fulfill your obligation. And then if you have multiple options for the end product, how do you decide how to take your components and build the optimal end result? And that could be not just physical manufacturing. That could be service delivery. That could be use of your human resources. And that's what I talk about generalizing the problem. You see something for supply chain, but it's not just manufacturing of automobiles. It can be deciding how to best optimize your limited staff because you have a shortage of staff. And it's sometimes not doing pure optimization, but because you know not everything is going to work out. You're going to have disruptions. So it can be looking for the lowest risk, you know, trying to find that balance of risk with some disruptions to still get the maximal output. So just the use case of one customer, it used to take them 3 weeks to do this massive analysis they had put together. That really did not allow, it could just sort of give them a yes/no if what they were thinking about doing was a good idea or not, but then they had no time to really come up with an alternative. It's now down to 45 minutes. That enables them to actually try multiple options in a day and actually optimize the problem. And lastly, you get to financial services, where I know several of you come from. And again, you have recommendation on one side. You're trying to find the best action, trying to recommend things to customers. But it's also internal recommendation. And then there's fraud detection, of course, or anti-money laundering. And you know why ML and AI are so helpful there. And again, first you start off with Graph being an ideal solution for Know Your Customer, because it really allows you to directly link things and build up as you gather more information about your customers. You link them directly and you see how they relate to other parties and other institutions. And again, it's very explainable. It's understandable by all the parties in your institution involved. And it also provides the basis for more automated methods of fraud detection. So looking forward at what TigerGraph is planning to do in the Graph plus machine learning domain, Graph plus AI. We already have the in-graph graph data science library. We're going to continue to work on that and add more algorithms, make it more usable, make it more tuned to the needs of today's data scientists. We're going to move into the neural network domain and support graph-based neural networks running directly in our product. And we're going to build, again, for data scientists and even less technical users, a graph plus machine learning workbench. Machine learning data scientists today, they have what they call their pipelines. They've got their ML ops, machine learning operations. They use Python, they use Jupyter notebooks, And then for less technical users, they have more graphical user interfaces. We are working on integrating TigerGraph into that standard workflow so it's seamless, it's familiar to them so they don't lose any time trying to learn a new platform, but giving them the power of the graph data, graph insight, graph analytics. I can go a little bit deeper on all of these, and then I'm going to try to wrap up because I know you're all looking forward to taking a break and having lunch. So the Graph Data Science Library, this is signaling our commitment to, we used to call it the Graph Algorithm Library. We've renamed it the Graph Data Science Library. We, this month, released 20 new algorithms. But it's more than just the algorithms. Again, a reminder, these run in our database, so you don't have to export the data. It can be updated in real time, the data, and it runs on our scalable, ultra-fast platform. And it's targeted at data scientists, which means it's going to be easier to use. It's going to be in their familiar, run via Python or run via Jupyter Notebooks, and it'll integrate into their existing pipelines. I want to kind of wrap up giving you a sort of a layperson's explanation of graph neural networks, something maybe you've heard about. So neural networks, many of you have seen a drawing like this. It looks like a graph. That's actually sort of representing the pattern of computation. You read it left to right of the data flow and the computation and it's sort of representing neurons in the brain. But the bottom line is they've proved to be a very powerful machine learning technique for predicting and classifying. Then you have graphs. Notice the structure is more irregular. The neural network is a very regular structure. The graph is modeled to fit whatever your data is. The structure is your actual relationships. And we said you get this, we've heard all morning about the insights you get from connected data. The idea of the graph neural network is to turbo boost what you can get out of a neural network by combining the two. And you come up with the graph convolutional neural network. And you may even hear about other things like graph attention networks and other types. They're just variations on the same theme. This is actually the most basic form. You add an additional step called the convolution step, and the convolution is looking at the neighboring relationships. So every particular node is influenced by its neighbor nodes, and you actually build that into the training process. So the graph is not just your data source, but it's actually used throughout the training process. So it's not just at the beginning, but it's throughout. And so you are, in this way, combining the insight from graph and the power of the neural network. And lastly, what is this graph plus machine learning workbench I've talked about? It's taking the power of TigerGraph, which has the graph data science library. It's going to have in-graph neural networks and other tools for data scientists, all within the TigerGraph framework. It's going to include added simplicity for importing your data. And for those systems, like I know we have representatives here today from system integrators, from cloud platforms, and they've got their own existing machine learning tools. And we have customers or we have users who have their own existing machine learning tools. And we realize that we're not going to be your only data source. And you're going to want to take your graph data and maybe combine it with other data and send that to your existing machine learning platform. That's fine. All of this is going to run on the cloud or on premises. It's going to be basically the same interface regardless. So again, it's really designed to take the environment that data scientists are used to using today and just making TigerGraph as easy as possible, the most convenient way to take advantage of what Graph has to offer. So thank you for your attention. I know you've been bombarded with information today. Take a break. Jay's going to wrap up, and then thank you.
This is awesome. So basically, I know I'm really the last person standing between you and lunch. So, but I also want to actually give you, there's a lot of information, but the next slide, hopefully you can remember. Still, it's more than 3. So what are the key takeaways? I think you can't forget about everything, but what you really need to remember is graph technology is mature, is scalable, is available for you to adopt today. You don't have to wait. Graph is beautiful. Remember, the mother of all data models in the most elegant, simplistic way to represent the real world. Graph is valuable, backed by many, many success stories from largest company in the world. Enjoy the basically deploying graph-based solution to create customer value and business benefit. Graph is real. It is scalable. We already reached 36 terabytes. As we speak, the engineering team is already working on 100 terabytes. And our vision is if we can support a petabyte level graph, I will argue, why do you need a data lake? Your entire data lake is a graph, a single graph. You can run anything by bringing machine learning and AI to the graph instead of the other way around. That's going to be game changing, but that's going to be 3 years down the road, 2-3 years. But for now, even at terabyte, 10 terabyte range, even from our customer, you get tremendous benefit. Graph is easy. As you see, we have a lot of innovation. We have delightful developer tools for you to adopt, to use. As I mentioned, when we actually tried that in front of the university students, sophomores, juniors, seniors, within 30 minutes, they can use our tools to solve real problems. And you can actually read about their blogs. I was blown away by some of the blogs. So creativity, a lot of creativity to map a problem into a graph problem and quickly find a solution for that. Graph is quick. As we mentioned, we innovate on turnkey solutions for you. We also have graph accelerators to simplify, to greatly reduce the cost, the effort, and also reduce the time to market. Graph is peaceful, rely on our great cloud partners. You don't have to worry. It's going to be on cloud. It's going to be managed for you. It's very easy to deploy and operate. And finally, what Victor has shared, the graph is really intelligent. We're going to bring all the AI machine learning to you. So with all this, let me ask this simple question. Is there any reason left for you not to adopt graph today? If you do, talk to me before you go to lunch. Thank you.